The Amur rocket is expected to incorporate advanced manufacturing techniques such as the use of composite materials, 3D printing, and bionic design to reduce weight while maintaining structural integrity. Manned spaceflight capabilities, co-orbital attack satellites, space station capacity, robust satellite constellations. These are just some of Russia's space capabilities today. While the Ukraine war has diverted all attention and most Russian resources away from other areas of Russian society, such as space, the Russian Federation continues to preside over the second most powerful space program in the world, behind the United States. Something that both China and Russia have desired to do is to catch up with the American advantage in reusable rockets. Well, Russia believes it has at least partly achieved this difficult goal. Russia's Amur-SPG rocket was developed by the Roscosmos State Corporation in collaboration with the Progress Rocket and Space Center. What is the Amur-SPG rocket? A partially reusable, methane-fueled orbital launch vehicle designed to replace the aging Soyuz family of rockets. Russia's Amur-SPG focuses on cost efficiency, environmental sustainability, and reusability. What's more, Amur-SPG aims to position Russia as a competitive player in the global space industry due to the reusable nature of the rocket. Also referred to as Soyuz 7 in earlier iterations, the Amur-SPG emerged from Russia's Project Phoenix, a mid-2010s initiative by JSCS-RC Progress to develop a new family of rockets to succeed the Soyuz series. Unlike its predecessors, which trace their lineage to the R-7 intercontinental ballistic missile ICBM, the Amur-SPG is a ground-up design, reflecting a real shift in Russia's space ambitions. Announced in 2020, the project aims to create a medium-lift, two-stage rocket capable of delivering payloads to low Earth orbit LEO at a significantly lower cost than existing systems. The preliminary design phase began in October of 2020 with a budget of around 70 billion rubles, or around $880 million. Moscow originally intended for the initial launch to take place in 2026, but due to the Ukraine war, that launch was pushed back to 2030. Cost effectiveness is the key element of the project. The Amur-SPG is a direct challenge to SpaceX's reusable rockets. One of the main reasons for why SpaceX has dominated the rocket sector has been the way that reusable rockets have drastically reduced the cost of spaceflight operations, giving the Americans a decisive advantage when placed against their foreign rivals. Now, Roscosmos intends to have their Amur-SPG cost around $22 million per launch, a significant reduction compared to SpaceX's $50 million per launch for their Falcon 9 reusable rocket. The adoption of methane as a propellant and designing a reusable first stage enhances the affordability of this system, making Russia more competitive against foreign rivals on the world stage. In the years following the collapse of the USSR at the end of the Cold War, Russia was able to successfully leverage their advanced space program into becoming what James Clay Knowles once referred to as the Walmart of rockets. But SpaceX crippled that competitive edge that Russian rockets had given Russian space firms in terms of capturing clients in the launch business. The Kremlin hopes that Amur-SPG will make Russia competitive again. Russia is taking SpaceX head on a two-stage rocket with a reusable first stage and an expendable second stage. The Amur-SPG is designed to deliver 10.5 tons to low Earth orbit in its reusable configuration and 12.5 tons in its expendable version, compared to Soyuz 2's 8.5 tons. The first stage is equipped with 5 RDO-169A methalox methane and liquid oxygen engines developed by the Chemical Automatics Design Bureau. These engines are meant for high reliability, with most expected to withstand 100 firings, and the center engine, used for re-entry and landing, targeted for 300 firings. The first stage features grid fins for attitude control during atmospheric re-entry and landing legs for vertical landings, drawing inspiration from SpaceX's Falcon 9. The second stage, powered by a methane-fueled RDO-169 engine, is expendable, reflecting a compromise between cost and complexity. As for the fuel source, methane offers several advantages over traditional kerosene-based fuels, including cleaner combustion, reduced engine wear, and better suitability for reusable systems due to its thermal and polymerizing properties. Additionally, methane is redundant and can be produced sustainably, aligning with global efforts to reduce the environmental impact of space launches. The Amur-SPG rocket is expected to incorporate advanced manufacturing techniques, such as the use of composite materials, 3D printing, and bionic design to reduce weight while maintaining structural integrity. These technologies aim to make the rocket competitive by 2026 to 27. Notably, The rocket's control system is capable of adjusting engine thrust in case of failure and diverting the rocket from the launch pad in the event of an accident, enhancing flight safety and dependability, making this a truly noteworthy system. Despite the innovative nature of this system, Elon Musk has wisely advised Roscosmos to push for full reusability in order to remain competitive globally, especially if the rocket in question will not be fully ready until the 2030s. At that point, the entire space launch sector may have changed.